So we're going to go ahead and get started. And I'm going to switch to my camera so we can start. Here we go. All right. So this is what we're doing. We have to fill this out. And what we're doing, we're going to be looking at the properties, all these different properties right here of these, I believe is what, 7 different elements. We're looking at properties of 7 different elements. Okay. 1, 2, 3, 4, 5, 6, 7. 7. All right. So we're going to start off. I want to show you what they look like because I actually have all 7 of these elements for us to look at.
What?
Yeah. These are the 7 elements. You can see them. Okay. This is, and I'll show it to you a little bit better, but this is our sulfur. This one is right here. Hang on. This is iron. Yeah, I have them in order. This one's iron. Then we have lead.
And then carbon.
Okay, lead. This one is carbon, right here, carbon. Okay. And then copper.
Everyone knows that's copper
Because of the color, yeah, yeah. Copper. And then this one is zinc. And then we also have aluminum. Right. And I'm also going to be using a battery and a Christmas light to check for conductivity. Okay. It does. I used it in my other classes. So watch. It does. I'll test it. Okay. Whoop. It did.
Hold on.
Look right there. Can you see the light? It does. See? It's hard to tell, but like that.
Can we turn off the light?
No, I'm sorry. I can't turn the lights off. Okay. And also, we're going to be using a magnet. So I have 2 magnets, but I like the little one. The little one's easier. Okay. So here we go. We are going to start. The properties that we're looking at, color. Okay. We're going to start with sulfur. So for color, here is my sulfur. Can you see it in the camera? What color does it look like?
Yellow.
Definitely yellow. Okay. So we're going to go ahead and we're going to write down yellow. We're going to write down yellow in the box for the sulfur. It's not. It's not really shiny. Yeah. Okay. Luster, right here when we look at luster, it says the way it reflects light. So look at it in the camera. I have the light on the camera too. Is it shiny?
No.
No, because if we want to compare it to something that's shiny, that would be like this. You see how it's like really shiny with that piece of metal? Yeah. Okay. So the sulfur is definitely not shiny. So right here, we're going to put dull. Okay, it's dull.
Is the sulfur squishy?
No. Okay. The next thing for brittleness, it says how easy it breaks. Okay, well, I want to show you something. I have this piece of sulfur in the bag, in this little baggie. What if I show you this? Is that better? No, the glare is kind of a, hang on. Let's try this.
Why not just turn off the light
Okay.
for the
Okay, so now you can kind of see it. Okay, so this is I had this piece of sulfur and it was 1 piece, okay, but I guess it fell on the floor and it broke into 2. And can you see this? It's a whole bunch of little pieces that broke off on the bottom. Can you see that in the baggie? So they're all in there in the baggie. So when they ask the question about, is it brittle? Brittle means that it breaks up into pieces, like how easily it breaks. Would we say that this is brittle?
Yes.
Yeah, we're going to definitely say yes. Because if it wasn't brittle, it wouldn't have broken up into the 2 pieces, and we wouldn't have all the little powder in the bottom of the bag like that. Okay. Now, magnetism, I'm going to get my magnet, and we're going to see if the magnet's going to stick to it. Okay. Oops. Let's try it again. Let's try it again. You never know. Come on, scientists always try things more than once. It slides right off. It does not stay. Okay. So we're going to say no for magnetism. Okay. The next thing is malleable. Okay, malleable, look at the definition. It says how well it can be hammered into thin sheets.
No.
Well, let's think about it. If y'all saw in the baggie that it broke into pieces and it was powdery and all that, do you think I could make this flat without it crumbling and breaking? No. So we're going to say for malleable, we're going to say no. And you know what? If you look at brittleness, brittleness kind of helps you answer the malleability part. Because if it's brittle, you definitely cannot make it flat because it'll break. Okay, conductivity. Conductivity is using the battery. So let's get this and we're going to look for that light bulb to see if it's going to light up. Okay, you ready? Okay, look at the light bulb. Oh, try it again. Hang on. Try it again. Anything? No. No, it did not light up. Okay, so for the sulfur conductivity, we're going to say no. Okay, now at the bottom, there's two boxes and it says more like sulfur or more like iron. Well, it is sulfur, so of course it's going to be more like sulfur. But wait, what we have to think about is think about these properties. Okay, we just did our vocabulary, so let's think about it. If something is dull, it's brittle, it's not attracted to a magnet, so no magnetism. It's not malleable and it's not conductive. Do you think that sounds more like it would be a metal or more like a non-metal? Non-metal. So let's do this because this is going to help us later. At the top of sulfur, let's put non-metal. Non-metal. Just write that on the top. Yes. Yes, what?
When I think of this, I think it's like negative because it breaks easily, it's not attractive.
Because it doesn't have all those things.
Yeah.
All right, the next one we're going to do is iron. Okay, so for iron, let's look. All right, here is my sample of iron. Yeah, if you look at it, it's silver. So we're going to go ahead and we're going to say silver for color. Luster, is it shiny?
Yeah.
Yeah, very. You can see the light reflecting back. So we're gonna say shiny. For brittleness, how easy it breaks. So is it brittle? Okay. Well, wait. Look at it. Look at this. I can bend it. If it was brittle, would I be able to bend it without it breaking? No. So if I can bend it, it's not brittle. So we're gonna say no. It's not brittle. Okay. Magnetism. Let's see if it's attracted to the magnet. Okay. Oh, yes, it is. Definitely, the magnet sticks to it. Okay.
It's like the exact opposite.
So we're going to say yes for the magnetism. For malleability, okay. Remember what I said. If you look at brittleness helps you answer malleability. So malleability, we want to know, can it be hammered into thin sheets? Well, look at the sample that I have up there. Look at it. Is it already a thin sheet? Yeah, it is. So it is. We say yes. It is malleable. You'll notice that if it's not brittle, it will be malleable. If it is brittle, it's not malleable. Okay. Hang on. One more thing. Let's do conductivity. Conductivity, let's see if it's going to light the light bulb. Okay, can you see the light? You ready?
What? Go.
Oh, it's shining.
I can't see anything.
It's shining. The light is shining. Okay, all right, so we are going to put yes. Okay, now notice that the properties of this iron, okay, oh, and by the way, at the bottom, see how it says more like sulfur, more like iron? Well, it's iron, so of course it's going to be more like iron.
I think it's more like.
But when you look at the properties, aren't the properties like the opposite of all the sulfur?
Yeah.
So If sulfur, those properties were a non-metal, what do you think iron is going to be?
Metal.
A metal. So let's go ahead and we're going to write metal. Okay? Write metal on the top. Metal. Yes.
Can it really be hammered into thin sheets if it's like hard, and if you hammer it, it won't do anything to it?
No, it can still be made into thin sheets because think of the video we saw yesterday. They had aluminum. Aluminum's hard,
Yeah.
but they put enough pressure on it that it did flatten out and get really thin. It took a long time, but it worked. So
Yeah,
you
but I
can.
bet you could do that to the sulfur if you did.
You can't do that to the sulfur because the sulfur is too brittle and it would break.
Usually you.
Yeah, so sulfur is not malleable. It breaks because it's brittle. So that's the difference.
I thought sulfur was a
Usually you
gas.
Yeah.
Well, the reason why you're able to get pieces of plastic, flat, is because you can melt plastic.
Yes, you can melt plastic, and plastic's not an element, it's a petroleum product. But yes, we can shape plastic into the shapes that we need.
Is everything that's not an element a compound?
Okay, lead. This is our next thing. Here's my piece of lead. You might just want to look at it.
Where did you get that from?
Okay. Well, hang on. Let's look at it. Look at the color of it compared to this.
It's like a little bit
Okay.
gray.
It's actually, okay, the one in my left hand right here, this one, we consider it to be silver. And this one right here, it's not black. It's hard to tell on the camera. It's gray.
So gray.
It's gray. So we're going to go ahead and we're going to say for the lead, we're going to say gray.
Gray gold.
And for the luster, is it kind of shiny? Look,
Yes.
look at it.
Yes.
Yeah, it is. It is. It's reflecting some light. Okay. So we're going to say shiny. For brittleness, watch this.
Whoa, that's really
Okay. So if it was brittle, could I bend it like that?
No.
No. So this is not brittle. So we're going to say no. Right? Magnetism. Let's see if the magnet's going to be attracted to it. Oh, no, try again. No, it just falls off. Okay. So for magnetism, we're going to say no. For malleable, remember what I said? Look at brittleness, and brittleness helps you with malleability. And malleability means you can make it into a thin sheet. Well, look at the sample that I have. Is it already pretty thin? Yeah. So would we say malleable?
Yes.
Yes, absolutely, because it is a thin sheet. Conductivity, we need to test it with the battery and the light, and we're going to see if it's going to light up the light bulb.
Can we make a prediction?
Okay, so watch the light.
Whoa.
Yes, hang on, let's do it again. And
It's like, it's kind
There
of.
you go.
bright.
sorry, it's hard to see with the glare of the camera, but look, can you see? You see
Yes,
the
I
light
know.
over there?
I know what it's
It
gonna
is.
be more like.
I take it off,
Yes, I see
and I
it.
put it back on, and there you go. It's because of the glare. I'm sorry. I'm trying to move it so it's not. There you go.
I see it.
Now you see it. You can see the
It
light.
looks like a
Looks
mini
red.
pink
Okay.
fire in there. I know what it's more like.
Okay, so here we go. For conductivity, we're going to say yes. Okay. Now, at the bottom, is it more like sulfur or more like iron? This is where we have to stop and we have to look at the properties of it. Look, the properties, almost everything matches with the iron, right? Okay, so we're gonna say that it has more in common with the iron than it does with the sulfur. So we're gonna check the box that says more like iron. Now, if it's more like iron with these properties, do you think it's going to be a metal or a non-metal? Metal. So let's go ahead and let's write metal on the top. Right there, metal. Question, yes.
An easier way just to know if it's sulfur or iron. If it's an iron, it wouldn't break easily. And
Not
if it was a
easily.
sulfur,
Not
it
always.
would.
Okay, carbon. All right, so here's my piece of carbon. And I had it in this baggie. Let me show you my hand. Okay, look, I had it in the baggie, and you can see that there's some pieces of it that broke off. Okay, so looking at those pieces of it, well, let's go back for a second. The color, let's look at the color first.
Wow.
Yeah, it's definitely black. You can tell in the camera. Okay, it's definitely black. Luster, is that shiny at all? Really? Okay, because this would be considered shiny. That is dull. Yeah, the luster is dull. Okay, brittleness. That's what I was showing you guys with the pieces in the baggie like that. Is it brittle? It's brittle. If pieces broke off, it is brittle. So we're going to say yes for brittle. For magnetism, let's try the magnet and let's see. Nope. Try it again. One more time. Let's try it. Yeah, no. Okay, so magnetism, no. Malleability, that means can we hammer this and make it flat into a thin sheet? Remember, look at your brittle, and that will help you figure out malleable. So if we said, yes, this is brittle and it's going to break easily, would it be malleable?
Yes.
Malleable means you can make it into a thin sheet. If this can break easily, then I won't be able to make it into a thin sheet because it would break when I try to hammer it. It would break. So for malleability, we say no. For conductivity, we're going to test it with the battery and the light. Well, we'll wait and see. Okay. Ready? Can you see the light bulb? Okay, here we go. Did it light up? No. Okay, try it again. No light on that light bulb. So we have to say no. For conductivity, we say no. Now, when we look at this, we need to compare all of our carbon. We need to compare it to sulfur and iron. So is the carbon, does it have more in common with the sulfur or more in common with the iron?
Sulfur.
Definitely with the sulfur, okay? All right. Now, this carbon is carbon. Look at its properties. It doesn't conduct electricity. It's not malleable. It's not attracted to a magnet. It is brittle. It's dull. Would that be properties of metals or non-metals?
No.
Non-metal. So up here at the top, we're going to write non-metal. Okay. They use it for different things. It can burn, and they can use it for energy, for fuel. Okay. Okay, copper is the next one. A lot of people are familiar with copper. Right. So here's my piece of copper. Okay.
It's a little bit brownish.
Yeah. So for the color, some people say brown or some people say bronze. So either one, you can't say copper because it is copper. You can't use the word copper to describe copper. We're going to say bronze, B-R-O-N-Z-E, or brown. Because compared to the other samples that we have, it's definitely more brown. The other ones are not. So,
What's that last letter?
bronze, B-R-O-N-Z-E, or brown. Now, luster. Does it reflect light from the camera? Yeah, you can see light shining back. So we say shiny.
Yes.
Is it brittle? Well, look at it. Look. If it was brittle, would I be able to bend it like this? No. If it was brittle, I couldn't bend it. It would break. It wouldn't bend. So for brittleness, we say no. For magnetism, let's check with the magnets. Okay. Try again. No. Okay. So no for the magnetism. Okay. Malleable. Remember, look at your brittleness, and that will help you with your malleability. So we said it's not brittle. So for malleable, can this be made into a thin sheet?
Yes.
Well, yeah, the sample I have is already a thin piece like that. So we say yes. And now we try for the conductivity. So again, we're going to use the battery and the lights.
I don't know about that. Yeah, I say no. I say no.
Okay,
I say no.
can you see my light bulb? Ready?
No. Yeah.
Oh, yes, it does for sure, right there.
That's
It
what all the
is.
wires are made
Hey,
out of.
and let me show you something. Remember I told you that most of the wires in our house are made of copper? Look, that's copper wire right there. Okay, a penny's made of copper as well. So conductivity, we put yes. Okay, now we have to decide, is this copper more like sulfur or more like iron? So look at the properties.
Iron.
Yeah, it is. It has much more in common with the iron than it does the sulfur. So we check the box for iron. Now, looking at those properties, it's shiny, it's not brittle, it is conductive, it is malleable, no magnetism. Would that be properties of metals or non-metals?
Metal.
Metals. So we put metal.
I have this thing.
What has a statement?
Yes, Wes.
The way I know it's a metal, if it conducts electricity, it is a metal. If it doesn't, it is not a metal.
Yeah, that is one of the main things to look for.
All metals conduct electricity.
Well,
Not all, but most.
we'll say most. We'll say most.
But
Yeah.
most.
Okay, our next element is zinc.
Copper does.
Okay, so here's my piece of zinc. So look at it.
Shiny,
Oh, definitely shiny.
and it looks bendable.
Okay, well, what's the color? What color would we say? Silver. Okay, so let's write down silver.
Do we have to do the back of this thing also?
Uh-huh. Okay,
Oh my
so it's silver. The luster. What did we say when we put it in the light? Shiny.
I see that.
For brittleness,
No.
is it brittle? Well, look at it, watch.
It's nice and thin.
Can I bend it?
Yeah.
Yeah.
If I can bend it, then it's not brittle. So we're gonna say no for brittleness.
This is the
Okay.
first time I've ever seen a boy.
For magnetism, let's check it with the magnet.
Sort
No.
of. Sort of.
Try it again, try it again. No, it doesn't. I balanced it on there, but as soon as I turn it, it falls off.
Oh,
So no. Okay, so for magnetism, we say no. Okay, malleability, remember, for malleability, go back up to your brittleness, and your brittleness helps you with the malleability. If it's not brittle, can it be malleable?
Yes.
Yes, because it says it can be hammered thin. That's what malleable means. And look at my sample that I have right here. It is a thin piece. Okay, so we say, whoops, we say yes. It is malleable. Conductivity, again, we check it with the battery. Okay, please stop making noises. Okay. All right, we're going to check it with the battery and let's see what we got. Okay, so watch it and let's see what we got. Okay, can you see the light? Okay, here we go.
It's a yes.
Ah, you see the little light? It did light up right there. So it is conductive. So we're going to write down yes. Okay. Now at the bottom, you have to compare it to the sulfur and the iron. Does zinc have more in common with sulfur or more in common with iron? Definitely with iron. So we're going to check that one off right there. And now, since it has more in common with the iron, and look at the properties of it, yes, it conducts electricity. Yes, it's malleable. No, it's not attracted to a magnet. It's not brittle. It is shiny, and it's silver. All of those properties, are those properties of metals or non-metals? Metals. So we're going to say metal.
And also,
Okay.
all of the ones that were like iron but not iron had shiny, no, yes.
Mm.
No, yes, yes.
Okay. The last one is aluminum. Aluminum. Here's my piece of aluminum.
That's way bright.
Oh, that's silver shiny.
Okay, so we're gonna go ahead for the color. We're gonna say silver.
Shiny.
Soda can.
It is definitely for the luster, it is shiny.
Yep, that's a shiny boy.
Now, brittleness. Okay, so look at it. If it was brittle, would I be able to bend it like that?
No.
No, because if it was brittle, it would break and it wouldn't bend. So for brittle, we say no.
And it wouldn't be that thin.
Okay. And then magnetism, let's check it with the magnet. Oh, try again. No, it doesn't. Like it just slides right off. So we have to say no for magnetism.
Conductivity.
And malleability, that is, can it be hammered into a thin sheet?
Yes.
Well, look at it. The sample I have is already a
Also
thin
the
piece.
video.
So we say yes. Yeah, and the video we watched yesterday too about the aluminum.
That aluminum.
And remember, don't forget, if you look at your brittleness, that will help you with your malleability. Okay? If it's not brittle, then you know it's going to be malleable.
Also,
If it is brittle, then it will not be malleable because
Like,
it was
can it be
break.
both?
No,
think of
it cannot be both. Okay, conductivity, this is it going to let electricity flow through it? So we're going to test it.
Let's say yes.
Yes,
Or can be
it
wrong.
is. Yes, it is.
We'll wait and see.
That's a hypothesis.
Yes, I say yes. It's my hypothesis.
I say
I
no.
say yes.
Okay, look at the light bulb. Let's see if it's going to light up.
I say yes.
Yes, it did. All right. So yes.
Yes, you are. Yes, you are.
Okay, so we say yes.
Yes, I was about to say.
Okay, now we have to decide, does it have more in common with sulfur or more in common with iron? Yeah, if you look at the properties, definitely more in common with iron. So we check off the iron. And at the top, we have to decide if it's a metal or a non-metal. So look at these. Yes, it's conductive with electricity. Yes, it's malleable. No, it's not attracted to a magnet. No, it is not brittle. It's shiny and it's silver. All of those properties are properties of
Metal.
metal, so we write metal.
Exact same properties of
Okay. All right, now on the back, we have some questions to answer. Now, if you look at this, do you see the three boxes at the top? The three boxes give you properties right there that help you figure out which ones are metals, non-metals, and metalloids. Okay? Metalloids are elements that sometimes act like metals and sometimes they act like non-metals, depending on their environment, like the temperature and the pressure that they're under, things like that. Okay? Okay. Semiconductor means exactly what I said. Sometimes it will act like a metal and be conductive with electricity and heat, and sometimes it will not be a good conductor. Okay, so semiconductor means sometimes it is and sometimes it's not. Okay, Jordan, question quick.
Can steel be like the same color as silver?
Yes. It's usually a little bit darker, but yeah, it's usually a darker silver color. Okay, let's start. Number 1. Based upon your results, which samples would you classify as metal? Well, you know how I had you write metal and non-metal on the top? This is the reason why. So y'all tell me, which ones did we say were metals? Okay, hang on, let's do them in order. Write them down. So we have iron. The next one was lead, copper, zinc,
Aluminum.
and the last one was aluminum.
How do you spell zinc?
It's on your paper. Z-I-N-C.
Let me guess what we're gonna put on the next thing.
And then what is your evidence? So what did we look at to help prove that these were our metals? Because these are the metals. What did we look at?
The properties properties.
Okay, but-
Sorry, yo.
No, you're fine. The properties, but which particular properties helped us prove it?
Conductivity.
Conductivity? Because metals, all of the metals conducted electricity. Was there another property that we looked at to prove that it was a metal, Jack?
Yes.
There's like, shiny.
Oh, yeah, they were shiny. All the metals were shiny. Luster, yeah, they were all shiny. What else did we look at? How about the color?
Yeah.
Yeah, what color were most of them for the metals?
Silver.
Most of them were like a silver,
But then some of them were
Green
like
and
brown.
silver or gray.
Brown.
Now, we know that copper is a little different than that. Copper is a kind of brownish bronze color. So, but it's still, looking at the color, most of your metals will be a silver gray color. Okay? Copper is just a little different from that, but most of them will be. Now, how about, what's another property that we looked at? Malleability. M-A-L-L. It's okay. E-A-B-A-B-L-E. Did I spell that right?
Yes.
M-A-L-L-E-A-B. Oop, L-E. There you go. When I talk, I
Oh, yeah.
can't spell right.
Sorry.
If I talk and write at the same time, it gets spelled right.
Why
It's
can't,
just like this way. You can't do two things at a
I
time.
know.
why can't we put
Okay.
copper for copper?
Because copper, even though we think of it as a color, copper is, you can't use that to describe something that is copper because it needs to be descriptive. So a little more so someone can understand it a little bit better. Yeah. Okay. Number 2, based upon your results, which samples would you classify as non-metals? So again, what were the ones that we labeled as non-metal?
Sulfur and carbon.
Yeah, you got it. Sulfur and carbon. So write that down. S-U-L-F-U-R
What is my
and carbon. Now for evidence, what were those properties that the non-metals had?
Brittleness.
Oh, brittle. They definitely were brittle. What else?
Shine. Like the shine.
What about the shine? Were the non-metal shine? No, they were dull.
Non-magnetic.
Oh, they were not. We're gonna say non-magnetic.
But some of the metals are non-magnetic also.
I know. Right. Some of them.
Non-conductive.
Oh, yeah, well, let's look. Hang on. If I look back right here, okay, these two right here are my non-metals, and they were not conductive. All my metals were conductive. Yeah. So when we just put, oh, we're looking at magnetic, sorry. So magnetic, you're right. Look, the other metals right here were not magnetic. So would magnetic or magnetism be something good to help us decide if it's a metal or non-metal?
Not really.
No, not really. So even though it's something good to test for, let's take that one off. So what's something else? I heard somebody say it. Non-conductive. Yeah, because all the non-metals, they are non-conductive.
very important?
Poor conductors, yes, that's what it means.
A good insulator.
They're good insulators. Okay. How about, are they malleable? Were our non-metals malleable? No. So let's just add this. Yeah, I know they're brittle. We're gonna say not. Let's just put not malleable. All right. Let's move on to number 3. Okay. Number 3. What properties were most helpful in identifying the metals? So what specifically do we want to look for to identify metals? Something that is definitely a difference between the metals and the non-metals. Look at what our non-metals had, these two columns right here, compared to all of our metals. What are 2 things that definitely tell us if it's a metal or a non-metal? Braden. Okay, conductivity, and I'm going to say malleable, but yes, brittleness goes along with that. Okay. So,
No.
right here for number 3, the 2 things for sure you always want to look at for metals is you want to see if it's malleable and you want to see if it's conductive. And if it's a metal, we're going to say yes for both. Now, if we're looking at non-metals, well, what do we want to look at to prove it's a non-metal? Could I use the same properties?
Yeah.
I could, but what am I looking for this time?
The opposite.
The opposite. So instead of it being malleable and conductive, it's going to be the opposite. It's going to be non-malleable and non-conductive. So we're going to put non-malleable. And I'm just going to say not conductive. Got it? And we have one left. Based on your results, which samples you tested would be suitable for making electrical wiring for a home, and then justify your answer. So if we want to make wires for our home out of the 7 samples that we had, well, what do we want to use?
A metal.
Well, okay, we want to use a metal, so for sure, we want to use a metal. What metals do you think would be good?
All of them.
Okay, hang on. What metals would be good? Ezra. Ah, absolutely copper. Oh, and did y'all notice that on my light bulb right here? Did you notice that the wire? Yeah, I showed y'all. Yes, copper wire. So, is there another metal that would be really good that we tested?
What, aluminum?
Okay, aluminum would be good. How about zinc? Does zinc work
Yeah,
too?
zinc.
Yeah, so we could use copper, we could use aluminum,
What about iron?
we could use zinc, okay? These metals are more flexible, and remember, if we're making it into wire, it's definitely got to be flexible, and you got to be able to make it into the wire. That word is called ductile, D-U-C-T-I-L-E. Do you remember they talked about that yesterday?
Yeah.
If you make it into a wire, it's called ductile. Iron, even though iron does, it is conductive with electricity and stuff, the iron is really hard and the iron is not really ductile. So you couldn't really bend it and shape it for wires. So that's why you probably wouldn't want to use iron. But these other ones, you can bend them better. Okay. Now, it says justify your answer. So we basically, what do we want to say? We want to say these metals, we could use these because why? Because
They are all conductive.
they are all, we're going to put this, we're going to say they are all,
Conductors and ductile.
yes, they are all conductors and ductile.
You know, ductiles
Uh-huh.
sounds like a Pokemon name.
Yeah, no,
Uh-huh.
Ductiles
Isn't
sound
it?
like a Pokemon name.
It does not.
Ductile. Like,
Y'all, perfect timing. That's a 5-minute timer. All right, so, okay, everybody in class, take your paper, make sure your name is on it, first and last name, and turn it in on the front table by the spray bottle.
This is a grade.
Yes, this is a great.
like if
Oh,
it was
no.
called,
Okay.
if it was called ductile,
And
it'd actually be a word.
Those of you that are at home that are online, make sure you fill it all out and you submit it electronically so I can grade it. All right. When y'all are done with that, you guys can exit Zoom because we're done for the day.
Can I just put D?